Hi everyone, this is Miss Faina. Today we're going to be talking about simplifying radicals, and we're going to talk about ones that are not perfect squares. So if you missed the perfect square lesson, go ahead and watch that video and then come back to this one. So as a reminder, we have our perfect squares. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. And we're just going to keep going. Square root of 64 is 8. Square root of 81 is 9. And the square root of 100 is 10. Okay, it's going to be helpful if you have the notes from yesterday when we go through this process. Okay, and then we just have some more, but I'm going to go ahead and skip those. Again, if you have your chart, you already filled this stuff out. So here we go. It says, simplifying the radical. Divide the largest perfect square that goes into the number evenly. So what you need to do is always look at your perfect square list. You want to start with the number that is closest to 20. Okay, so if I think about it and I look back here, okay, I'm not going to want to start with anything bigger than 20. So that means I can eliminate 25, 36, and all those below. So I'm going to start at 16. What I'm going to do with my calculator is I'm going to take 20 and divide it by 16. If it divides evenly, then it works, cool. If it doesn't, I move on to the next number, okay? Which means I would go and divide it by 9, which would be the next perfect square. If it works, cool. If not, I keep moving, okay? So I'm going to go ahead and switch over to the calculator, and I'm going to add a new calculator. So again, I take 20, I divide it by 16, okay? Notice how it gives me a fraction. That means it does not divide evenly. So I can skip that and go to the next one. So I said we were going to go to 20 and divide it by 9. Again, it gives me a fraction, which means it does not divide evenly. Just to show you, divide evenly means I would get a decimal. So if I take 20 divided by 16 and I put a decimal point there, notice how it's a decimal. If I take 20 and I divide it by 9 and I put a decimal point after the 9, I get a decimal. Okay, so the next square root, so those did not work. After 9 would be 4, so I'm going to try that one. So I'm going to take 20, divide it by 4, and notice how I get a nice, pretty whole number. That is what I'm looking for, so 5. So when we go back to our notes, what we're going to do is we're going to say, hey, 4 goes in this one, 5 goes in this one. Well, we know the square root of 4. The square root of 4, we did that yesterday, is 2. And if we look at our perfect square list, 5 is not a perfect square, therefore it doesn't get to leave the radical. Okay, it can only leave the radical if it's perfect, and it's not perfect, so that would be our final answer. How we would say this is 2 square root 5, or you can say 2 rad 5. They mean the same thing. Okay, so let's look. I have a few more examples for you. Okay, so we have 18. So I'm going to start, again, we have our perfect squares, so I'm going to start listing them. We have 1, 4, 9, 16, and 25. Okay, 25 is too big, so I'm going to start with 16. So I'm going to take 18 divided by 16. So 18 divided by 16. I'm going to put a decimal point so you can see I get a decimal. So I move on to the next perfect squared, which would be 18 divided by 9. Go ahead and put a decimal just to be safe. It works, 2. Okay, so what we do is we put our perfect square. So that was our winner chicken dinner. We have 9 times 2. That gives us 18. Well, we know that 9 is a perfect square, so it gets to leave. Okay, so again, that's our perfect square, which means it gets to become 3. And 2 is not on our list, so it has to stay on the inside. So our answer would be 3 rad 2 or 3 square root of 2. Now, how you can check yourself, but you have to be careful because we're not going to accept decimals as answers, is you can take the square root of 18, see what you get, and then square root, or 3 rad 2, and see what you get. So what I mean is if I do the square root of 18, notice how I get that decimal. If I take 3 square root of 2, do I get the same decimal? Yes. That's how I know I did this correctly. Okay, so we checked our work. Perfect. Okay, moving on to the next one. We have 90, the square root of 90. So I'm going to list my perfect squares. So I'm going to start at 100, which again, that's too big, so it's not going to work for it. But we have 81, 64, 49. And again, if you have your list, you're just going to be able to write these numbers down as you look at the list. So that's 7 squared. We have 36, 25, 16, 9, 4, and 1. Okay, we always want to start with the biggest number because sometimes these numbers have 2 perfect squares that go into it. We want to make sure we have the biggest. So I'm going to start with 81. So I'm going to take 90 divided by 81. Okay, I'm going to get a fresh screen so we can see everything we do here. Okay, so I have 90 divided by 81. I'm going to put the decimal point. Okay, notice I get a decimal. So I'm going to move on to the next one. 90 divided by 64. Put a decimal point. Again, I get a decimal. I'm going to take 90 and divide it by, that was 8 squared, so 49. I forgot a decimal, but again, we're getting a fraction, so it's going to be a decimal. Okay, 90 divided by 36. Again, another decimal. 90 divided by 25. Again, another decimal. It doesn't work. 90 divided by 16. Again, we get another decimal, so it doesn't work. And 90 divided by 9. Winner, winner, chicken dinner. Okay. So 9 times 10 gives us 90, and 9 is a perfect square. So we have 9 times 10. Again, 9 is a perfect square, so the square root of 9 is 3. If we look on our list, 10 is not a perfect square, so it stays inside the radical. So our answer would be 3 rad 10. To check our work, we take the square root of 90, we get a decimal. We do 3 rad 10. Do we get the same decimal? Yes, we do. Okay, so that's only how we can check our work. Okay, looking at the next two, we have 180. Okay, so let's see, we got to start with 13 squared or 14 squared. That's 196. That's going to be too big, so we're going to start with 169. That's 13 squared. 12 squared is 144. Then we have 121, 100, 81, 64. Again, I'm just listing the perfect squares. Okay, 49, 36, 25, 16, 9, 4, and 1. Okay, so now we're going to go through and see which number is going to divide evenly into 180. So I'm going to start with a fresh, clean page. Okay, so 180, I'm going to divide it by 169. Again, I get a decimal. 180 divided by 144. I get a decimal. 180 divided by 121. Still another decimal. 180 divided by 100. Again, a decimal. Okay, again, I don't want a decimal. So 180 divided by 81. Another decimal. 180 divided by 64. Yep, you guessed it, another decimal. 180 divided by 49. Decimal. 180 divided by 36. Finally, a nice, pretty even number. So 36 times 5 gives me 180. So 36 was our winner chicken dinner. It was a perfect square. So we have 36 times 5. 36 is our perfect square. The square root of 36 is 6. And 5 was not on our perfect square list, so it stays as 5, and that would be our final answer. Okay, looking at the next one, square root of 32. So I can start with 36, 25, 16, 9, 4, and 1. Okay, so I'm going to start dividing. 36 is too big. It's bigger than 32, so it's not going to work. So we're going to start with 25. I'm going to start with a new page. Okay, so I had 32 divided by 25, decimal, 32 divided by 16. It looks like that one works. So 16 times 2. Okay, 16 times 2. So 16 is a perfect square. And that would be 4. And we get 2. Okay, so this is how we're going to simplify radicals. So make sure that we are starting from the bottom or the biggest number and working our way to the smallest number so we can find the biggest perfect square that goes into it. I'm going to put it back on the steps, so if you want to look at them, take a screenshot of them. There's the steps. If you have any questions at all, please reach out to your teachers. Other than that, have a great day, Ranger.